Good afternoon, everyone. Today we're going to factor two quadratic polynomials. The first one with an a value of 1, right? The leading coefficient of x squared being just 1, so x squared minus 2x minus 15. And the second one with an a value, the leading coefficient of anything that's not 1, right? Here it's 2. So for the first one, we have y is equal to x squared minus 2x minus 15. If we want to use the algebra tiles and kind of build a visual model of how this factors out, right? Looking at the dimensions of the rectangle that we're going to build by organizing the tiles in a specific way. We know we have the x squared to kind of start things off. Next, we need to have a total of negative 2x, right? But that can be, you know, a combination of positive and negatives, right? And we know we want to have negative 15 as the constant term. So 15 negative units, shaded in units, at the very end. And those usually fall into a pocket down in the bottom right-hand corner, right? So we want to lay out some x rectangles, right? Because the positive x's are the rectangles and the shaded in rectangles are the negative x's, right? We want to use some combination of these so that it creates this pocket for the 15 negative units to be drawn into, right? And since we need the sum of those x's to be negative 2, we'll most likely need a positive and a negative, right? And we know that to be the case because then when we multiply them, a positive times a negative will give us a negative product for the constant term down here. So if you can think of those two numbers that add together for a sum of negative 2 and at the same time multiply for a product of negative 15, right? Multiply for a product of negative 15 and simultaneously add for a sum of negative 2. Those two numbers are negative 5 and positive 3. Negative 5 and positive 3. So we can draw, over the green, we can draw however we wanted, just because of how I kind of drew the rectangle to start off. I'm going to draw the 3 positive x's, the 3 rectangles, laid flat like so, and I'll draw, I'll use the red just to emphasize the negatives, right, and I'll shade them in. These are the negative x's, right? I'll make those negative just to really highlight the difference between positives and negatives, right? 3, 4, and 5 negative x's, right? And now the 15 units are also negative, right? So we can make those negative. We get 3 rows of 5 columns, which works out perfectly. Now we can shape them in, right? Because they are negative 15 units. And now we'll look for the dimensions of our rectangle. You see a perfect rectangle being made. So the first dimension will have x plus 3. We know that 3 has to be positive, right, from our little factor work over here. And this dimension will be, we have a positive x and we have 5 negatives, right? So x minus 5. And those two dimensions, just like we found over there by factoring normally, provide us with our two factors. So we get negative 5 and positive 3. So x minus 5 and x plus 3, just like the dimensions of our rectangle kind of lead us to. Okay. Again, as you get a little more comfortable, feel free to give way to the algebra tiles and just factor using your knowledge of numbers. But for now, maybe you could have to build. And now here I won't draw it out because obviously it's good to get used to factoring normally. So when we have a coefficient of x squared that's not just 1, we're looking for a similar strategy, but now we want two numbers that multiply to make not just 6, but 2 times 6, right? So the a value, the x squared coefficient, times the constant is going to be 12. So they have to multiply to make 2 times 6 is 12, and they still need to add to make the middle coefficient. So they have a sum of negative 7, okay? Now, you can take your time, think those through, but you'll eventually find negative 3 and negative 4 as the numbers that satisfy those two conditions. So now we can't just jump right down to the factors because of the fact that we have a coefficient of x squared that's not just 1, right? It's a little less convenient to work with. So what we have to do is, this is called the decomposition, a term you'll hear quite a few times. We're going to decompose this middle term, the negative 7x, into negative 3x plus negative 4x, right? So we'll have 2x squared and plus 6, those will stay the same. And the negative 7x, we decompose it into negative 3x and negative 4x, like so. And now our goal is to factor the first two terms and factor the last two terms. So what we have is y is equal to, what can we pull out of 2x squared minus 3x? All we get is an x, and inside the brackets, we would get x times 2x minus 3. And now what can we factor out of negative 4 and 6? We factor out a negative 2, right? Minus 2 times, and then again, 2x minus 3, right? And we know that we are on the right track when we have the same expression in both brackets. So if you look inside, we have 2x minus 3 in both brackets. So we know we're on the right track because now we can write this quadratic polynomial completely factored as the first factor is going to be the stuff on the outside. So the terms on the outside of the brackets are x and minus 2. So the first factor is x minus 2. And the second factor is the expression inside the brackets, namely 2x minus 3. And there is our polynomial in factor form. And there we go, okay? Alternatively, if you do want to try the visual model of it all, you can use the algebra tiles. Draw 2x squares. Make sure you have 7 x's negative in total, right? You'll end up with a certain amount of positives, a certain amount of negatives, or maybe all negatives. And you'll have 6 positive units in the end, and it should work out to make a perfect rectangle, like you see in example 1. So I hope this helps. Thanks for watching. Take care.